Alright, chapter 4.4 is complex numbers. We should have an idea to answer the following questions. The square root of 16 is 4. The square root of 49 is 7. Why? Because, I was about to say, is that even showing up? Why? Because 4 times 4 is 16. 7 times 7 is 49. We know that to be true. Unless you've been here before, you have not been shown how to answer the following questions, because our first idea is to say negative 3 and negative 5. But what is negative 3 times negative 3? It is actually a positive 9, just like negative 5 times negative 5 is actually a positive 25. So those are not our answers that we are looking for. Because we're in a higher level of mathematics, we are expected to find the value of the problems above. And so 300 years ago, someone came up with a method of dealing with the impossibility of answering this question, because there is no true answer to a number that multiplies by itself to be a negative. It can't happen, because a positive times a positive is positive, so it can't be a positive number. And a negative times a negative is also positive, so it can't even be a negative number. So how do they deal with it? The idea is pretty simple. We understand that the idea doesn't actually exist. So in that case, we understand we will be implementing an imaginary number. And we're just going to call it I, because I, being creative, stands for imaginary. In order to deal with the negative portion of the value, we're going to assign the value of negative 1 for I. So I is equal to the square root of negative 1. And this allows us to do the following. We can now separate this to be square root of negative 1 times square root of 9, because 9 times negative 1 is negative 9, which means that this turns into I. This turns into 3, which makes the answer 3I. Alright, same thing here. The negative hurts us, so we're going to take the negative 1 out and leave the 25. The negative 1 root turns into I by definition. This turns into 5 by what we know, which means in the end our answer is 5I. And so that is pretty much what happens there. So any value that includes an imaginary unit is called a complex number. Fortunately for math numbers, there are other applications of imaginary number that we'll learn about in today's lesson. For example, simplify. I to the second. That would be square root of negative 1 times square root of negative 1, which would be negative 1, because of course your square root would be by itself, and so I to the second is negative 1. I to the third is going to be square root of negative 1 times square root of negative 1 times square root of negative 1. Well, we know that these two make negative 1. We know that this makes I, so the I to the third would be negative I. I to the fourth is square root of negative 1, square root of negative 1, square root of negative 1, square root of negative 1. We know these two makes negative 1. These two also make negative 1, which when you multiply them makes the answer of 1. So overall, here's what you should memorize, and here's what you have to memorize. I to the first is I. I to the second is negative I. I'm sorry, it's negative 1. I just put that. I to the third is negative I, and I to the fourth is 1. If you memorize those 4 things, then the rest of these will be just fine, because again, I to the first is going to be itself. I to the second we just proved is negative 1. I to the third we just proved is negative I. I to the fourth, because it would be I squared, would be a positive 1. So how do you deal with it if I have 35 i's? Well, what you do is, since this goes in iterations of 4, you just divide 35 by 4 and analyze the remainder. 8.75 the 0.75 means the remainder is 3. If the remainder is 3, that means it's the same thing as I to the third, which means it would be negative I. That is how you answer that. Alright? So how would you do I to the 72nd? You would do 72 divided by 4, which is 18, I believe. The remainder for 18, as you'll see for yourself, is 0, because it has nothing on it. And so since the remainder is 0, then you're looking at a whole number answer, which means that it's going to be 1. There's no way to write that one. Sorry. 341. Again, what do? You do 341 divided by 4. Which is 85.25. The 0.25, because you're dividing by 4, means my remainder is 1 because you have a quarter left over, which means it's the same as I to the first, which is I. And 1002, again divided by 4, is 250.5. Again, the 0.5, if you're talking quarters, means that the remainder is 2, which means we're looking at the same thing as I squared, which is -1. So again, that's a skill you're going to need, but just remember, you divide by 4, use the decimal portion. 0.25 would be a 1, 0.5 would be a 2, 0.75 is a 3, and if there's nothing attached, then you're looking at the fourth. But again, ask questions. That's what I'm here for. If you ask and I can help you understand it, you will get it and you will be just fine. Another thing you are going to do is an algebraic extension of it, which is to combine terms. And again, in terms of general math, it's just like an x. So what we'll do here is 8 plus 3i minus 5 plus 2i, because remember that this switches both of those, which means that this turns into 3 plus 5i. And that's all you have to do there. Again, you can't do anything with it, but the key thing is that you cannot just leave an I squared or any other type of I out there. You have to simplify it like what we just did. Another thing you're going to do is simplify a root. Now, I don't know if you remember this, but again, this is a Algebra 1 tactic, and what I usually do is I pull out perfect numbers. So in other words, my perfect numbers are 2 squared, which is 4, 3 squared, which is 9, 5 squared, which is 25, 7 squared, which is 49. And so I take those numbers out and I see, can 108 divide by 4? I cannot type today. Yes, 4 times 27. As long as it goes in clean, that's what I'm going to use. 4 no longer goes into 27. This number's good, but 27 is no longer with 4, but 9 goes into 27, which is 9 times 3. And so what I have here is the square root of -1, because there's a negative there, times 4 times 9 times 3. So this is going to come out as an I. This is going to come out as a 2, because the square root of 4 is 2. This is going to come out as a 3, and that 3 has to stay in because it's not a perfect number. In the end, 2 times 3 is 6i. Root 3 again, 2 times 3, 6. The I is out there. The root 3 stays on the inside, and that's what you're looking at. So again, taking the root, breaking it down, 4, as you saw, turns into a 2. This turns into a 3. There's your 6. The negative means I have an I. The 3 being left over is what's left over there. When you see this question, you will have to make sure that you multiply it out first, but be careful, because again, this is actually I would just break it down into its root. This is -1 times 4 times 2. This is -1 times 2 times 13 is the only thing I know about that. But here's the good news. I can actually take the negative ones out as an I here and an I there, which means that I have I squared times, let's just go ahead and put all this back in. 4 times 2 is 8. 16 times 13, which I should know, but I don't. The key thing there is that both of these negatives is an I here and an I there, which means it's actually I squared. And if you don't put the I squared out there, you forget about the fact that I squared is actually negative and you miss the whole problem. But other than that, my 208, remember my numbers, 4, 9, 25, 49. If you memorize those numbers, it becomes easy. 4, 9, 25, 49. So divide by 4, you get 4 times 52. Let's check that 4 again. Yep, 4 times 13. There's definitely nothing that goes into 13, which means that this comes out as a 2. That comes out as a 2. And so 2 times 2 would be 4i squared root 13. Remember that I squared is the same as negative 1, and so it's negative 4 root 13. Again, I expect you to ask questions. I am giving you this for the basics of it, but you should be asking for assistance as you continue to move forward, because that is actually what makes you a high-level math student, not knowing everything, but actually knowing how to ask with your notes, to do your part to study your notes, try it to the best of your ability, and then ask for assistance where you need it. That is what makes you a top-level math student. So I leave room for that, and I expect for you to ask on things that you're stuck on so that I can help you. Solve this. Well, what I know is that we can subtract 24. I know that we can divide by 2. And I remember from last year that if you want to, actually it might have been earlier, but I know that if you want to solve a square, you square root both sides, and so you end up with plus or minus root 12. I'm sorry, root negative 12. But this needs to be simplified, and so I have to go off to the side. I know that that's 4 times 3. That means a 2 comes out. It also means, because it is negative, that an I comes out, so this would be plus or minus 2i. Again, the 2 is because of that 4, the I is because of the negative, and the 3 had to stay. I will tell you again that you should have learned how to do the general idea of breaking those things down in Algebra 1, and again, if you did not, let me know. I will gladly find the information or get you some explanations that you need to get to where you need to be. But this is up to you to make sure that you do your part to study and kind of fill in those gaps. Another thing you'll be asked to do is to distribute with i's. So you will do 7 times 9 is 63. Minus 28i. Again, treat it just like an x at first. Plus 9i. Minus 4i squared. I would simplify first. 63. Minus 19i? Minus 4i squared. But the key thing here is I squared is the same thing as negative 1. And so what negative 1 ends up doing, 4 times negative 1 is going to turn this into, again, your note here is that I squared equals negative 1. It's going to turn into this, because it's a negative 4 times negative 1, which means now these two things go together to make that answer. The general rule with I, if you're talking imaginary numbers, is you should never have an I squared because that's negative 1. You should never have an I to the third because that's just a negative I. And you should never have an I to the fourth because that's 1. So you should never have an I with any power on it, and if you do, you must convert it and then simplify it even further if necessary. And the last question you're going to see in this work today is a rule called conjugating, conjugating the denominator. And what we're going to do is create what we call a complex conjugate. Again, this is your process. It is just a process, but once you practice it, you will get it. The first thing is you have to get rid of this I on the bottom because you can't have an I on the bottom. And so what we will do is we will multiply by a value that eliminates 3 plus 5i. And so the value we will use is 3 minus 5i. But in order to keep things balanced, we will do that on top and bottom. So when you do that here, you end up with, on the top, 21 minus 35i minus 12i plus 20i squared over 9 minus 15i plus 15i minus 25i squared. Make sure you verify those numbers. 7 times 3, 7 times negative 5 with an I on it, negative 4 times 3 with an I on it, negative 4i, negative 5i. So those match. 3 times 3, yes. 3 times negative 5i, yes. 5i times 3, yes. 5i, negative 5i, yes. Now the reason we wanted a complex conjugate is because if you look at the bottom, these two things are opposites, which means these two things go away. The other thing we just learned is that the I squared is -1, which means that this actually turns into a positive 25, which means we actually end up with 34 on the bottom. The 9 is still there. The 15 i's went away. This turned into a positive 25. 25 and 9 make a positive 34. The only thing we have to do now is simplify the top. And so the I squared being -1 means that this is actually a -20, because again it's 20 times -1. 21 minus 20 is 1. And then these two things make minus 47i. And that would be your conjugate. So that is the work for today. Combine that with your 30-something minute lesson from yesterday. I hope that you started this early, because if you did not, if you waited to take your first test and now you're doing this at the end of the week, you're probably going to be disappointed with your test score unless you do a whole lot of late night work. But again, I did warn you starting last quarter, so I hope you listened. Other than that, make sure you answer the question at the end of the video so you get your credit. And again, make sure you're asking for help. Good luck.